Hello there, welcome to the second video for section 1.3. In this section we're going to talk about the two basic types of research studies, the observational studies and experiments. And we're also going to talk about confounding or lurking variables. So let's get at it. Here we go. Observational studies is what we'll start with. We'll talk about lurking or confounding variables, and then we'll talk about experiments. So, what is an observational study? An observational study is one in which subjects in the sample are only observed. The researchers do not manipulate the environment or the conditions under which the data is collected. So what are some examples of these types of studies? Well, perhaps you wanted to examine the relationship between conviction rates and race in the U.S. This is not something that you can really control the environment about, but we can go look through police records or judicial records, and we can get the information from those records. So all we're doing there is we're just observing those records. So that makes this an observational study. We might research the relationship between industrialization and climate change. Well, again, we can't manipulate these quantities, these variables. I can't just make a whole bunch of industrialization and then go expect to measure a meaningful result in the climate. I don't have the ability to do that. But what we could do is we could look through the records of how industrialization has increased over time, and also see what has been going on with climate change. And finally, determine whether lifespan is related to alcohol consumption. I don't think it would be ethically appropriate to give people different amounts of alcohol and then force them to consume that for the rest of their lives and then see how long they live. That's just not ethically feasible, isn't appropriate. But we could look at people, we could look at people's lifespan and somehow get some information on how much alcohol they happen to have drunk. So we're just collecting that information. So we're just doing an observational study here. Okay. So what I want to do, I want to look at this graph here. I want to point out something that we have to be careful about when dealing with observational studies. So this is an interesting graph. It's a made-up graph, but you could imagine that something like this would probably be pretty accurate. So here we have, as time goes on down there on the x-axis, we're plotting two different things: shark attacks and ice cream sales. And I just realized my face is in the way here for that little sentence. So we can see that as we move throughout the year, as we get to the warmer months here, both shark attacks and ice cream sales go up. And then they both drop down together. So they look like they're tied together. So based on the graph on the left, should we infer that eating ice cream makes people more tasty to sharks? I mean, that graph seems to indicate that they're tied together, right? Well, of course not. Of course, that's a ridiculous thing to assume. And the main rule here is that we shouldn't infer causal relationships from observational studies. A causal relationship is a cause and effect relationship. One thing causes another. I shouldn't infer that just because these variables are associated, I shouldn't infer that ice cream sales causes shark attacks. So making causal conclusions based on experiments is often reasonable. However, we should be more careful when drawing causal conclusions from observational data, which is what we have here. Observational studies are generally not only sufficient to show associations or form hypotheses that we'd later check using an experiment. So, just a question here: what would explain the relationship between shark attacks and ice cream sales? Think about that. Why would they be tied together? Well, I'll let you think about that when we go to the next slide. Okay? And let's look at another example. Here we have an observational study that tracked sunscreen use and skin cancer, and it was found that the more sunscreen someone used throughout the year, the more likely the person was to have skin cancer. Does this mean that sunscreen causes skin cancer? No, we got the more sunscreen you use, the more likely you're going to get skin cancer. So it seems pretty convincing, maybe? Or could there be something else explaining this? And sure enough, there is something else explaining this. Sun exposure, right? I mean, if you're going to be exposed to more sun, you're going to use more sunscreen, hopefully. Not everybody, but a lot of people do. But you're also more likely to get skin cancer. So it's sun exposure that's actually causing the increase in sunscreen, and it's also causing the increase in skin cancer. And it's making it look like maybe one is causing the other, but in fact, they both just happen to be related to sun exposure. Right? So we call sun exposure a lurking variable. That's an extra variable, which you may not have accounted for at first, that influences both the explanatory and the response variables. And it may make them seem like they're associated, like they're causally related, when in fact they are not. So sun exposure here is a lurking variable. So let's go back to our, let me get my face out of the way so you can read that. And let me go back to the previous slide and ask again, what's going on here? Can we identify what the lurking variable is in this study with the shark attacks and ice cream sales? And sure enough, you should have thought of something about the climate, right? When the climate's warmer, during the seasonal climate, I mean, when it gets warmer in the year, more people are going to go swimming, and more people are going to be eating ice cream. And so if there are more people are swimming, that's when more people are going to get eaten by sharks, right? So it's really the warm weather that's driving the relationship here between both of these variables, and it's making it look like there might be a cause and effect relationship when in fact there is not. So the warmth of the weather is the confounding or lurking variable here. Okay, so this is something you have to be very careful about with observational studies. It's very hard to rule out these lurking variables. And it's also a reason why you shouldn't trust observational studies very much. If you get information about some new fact, always question what kind of study was it from. If it's from an observational study, we have to be very skeptical, and we shouldn't infer that there's really a cause and effect relationship there. It might be cause to do more experimentation, do further study on it, and investigate it. So observational studies do have their use, but we should be very skeptical about drawing conclusions from them. So what do we do? What do we do if observational studies aren't that useful for us? Well, we do a different kind of study. We do an experiment. Okay, so I'll move out of the way here so you can see the picture that I painstakingly dug up for us. Experiments are studies in which researchers manipulate the explanatory variable and make measurements to detect any associated changes in the response. Now, contrast that with observational. Observational, we're just observing, right? We're just observing. Here we're actually manipulating we're manipulating stuff. We're messing around with stuff. Now, why does it make sense to do that? Well, just imagine that you encountered some radio type device, all right, and you were curious about what this knob did. All right, well, what would you do to find out what the knob did? Well, you'd probably wiggle the knob, right? You wiggle it and see what happens, right? So you want to manipulate it and see if you can measure an effect. And this is something that you can do because you have that thing right in front of you, right? So this is the idea of an experiment. We want to wiggle that explanatory variable and see if we can measure a response in the response variable. All right? So we'll look at some example. We'll look at an example of an experiment later, but let's go through these properties of a good experiment. So number one here, the conditions under which the experiment is conducted are carefully controlled. Okay, so we're going to be very careful to control the conditions. We have the freedom to do this. Now, why would we want to do this? We want to ensure that no outside factors, especially lurking variables, can influence the results. So this is an opportunity to think about what those lurking variables might be and try to snuff them out. Try to get rid of them. And that's something we try to do in an experiment. Secondly, usually the subjects, if they're humans or animals, or items, if you're just sampling chemicals or something like that, the things being studied will be randomly assigned to separate groups. A control group where no treatment is administered, and one or more treatment groups that receive various levels of treatment. Analysis across these groups should detect any effects of the explanatory variable. So remember when I talked about the knob wiggling, right? Now if I just wiggle the knob and then hold my, while I'm wiggling the knob, hold my ear to the headphones, okay, I might hear some noise, and then I put everything away. Does that mean the knob was making the noise? Well, I don't know, because that noise may have been there even if I wasn't wiggling the knob. So how do I determine if the knob was causing the noise? Well, I have to first listen without wiggling the knob, and then wiggle the knob and listen. So I have the control where I'm not wiggling the knob, and I compare that to the treatment where I am wiggling the knob. And by measuring the difference, that's how I know that the knob is causing the effect. So that's why we have this control group. That's the group where nothing is happening, and we're going to compare that to the treatment group where something is happening. And we're going to see if we can measure a difference. And if we measure a difference, then we can say that it looks like that explanatory variable that I'm messing around with is causing the effect. The next step, efforts will be made to eliminate any potential bias from the researchers. All right, so the researchers may cause bias in the experiment. I mean, we talked about this in a previous video, and we talked about how hard it is to avoid causing bias. And so we can try to take steps to eliminate that bias, to prevent it from happening. Do things to try to make it so no bias can influence the results. And then finally, the experiment is reviewed for ethical concerns before it's carried out, and the experimental process is rigorously documented while respecting the privacy of the subjects involved. So if we do an experiment, we always want to make sure that we aren't violating any ethical principles. And this is particularly relevant when we experiment on animals or humans, right? We have to be very careful about that. And when you experiment on humans, you have to also be careful about privacy, right? When you publish the data, you don't want to share their name. You want to make sure that the humans involved understand the ramifications of being in the trial, what's going to happen with their data, who's going to be able to see it, how much they're going to be able to see. All these things are very important. So before we run out and conduct an experiment, we need to make sure that we're being responsible about it. Okay? Okay, so what I want to do now is look at some examples. And what we're going to do is we're going to identify whether they are an observational study or an experiment. Okay, so let's go ahead and go to my browser here. I pulled up some studies that I found online. These are real studies, real articles. So this first one is hopefully I can pronounce these here. Hydroxychloroquine with or without azithromycin in mild to moderate COVID-19. Yes, got it. So you may have heard of hydroxychloroquine. Some people have been talking about how it might be a potential treatment for COVID-19, right? And so this study was testing it along with some other drug there. And if we look down here, it says, let me skip to the chase here. Okay, methods. We conducted a multi-center randomized open-label 3-group controlled trial involving hospitalized patients with suspected or confirmed COVID-19 who were receiving either no supplemental oxygen or a maximum of 4 liters per minute of supplemental oxygen. So those are the subjects that they're looking at. Patients were randomly assigned in a 1-to-1-to-1 ratio to receive standard care plus hydroxychloroquine, or standard care plus hydroxychloroquine plus this other drug. So they're comparing 3 different groups, and they're subjecting them to 3 different treatments. And then they looked at the outcome. So the question is, what kind of study is this? Is this observational, or is it an experiment? So think about that. Maybe pause the video if you need to. Okay. So the answer is that this is an experiment. And we know this because it's a carefully controlled study. They're being very careful about how they're controlling the environment that the patients are in. They're talking about the level of oxygen they're receiving. They're being very specific about keeping that regular so that we know that that's not a lurking variable that could be affecting things. And we are changing something. We're wiggling something around here. We're changing the type of care that they're receiving. So we're looking at standard care, the hydroxychloroquine, and we're looking at the hydroxychloroquine plus azithromycin. So by administering those 3 different treatments, we can measure to see if there's an effect, right? And so that makes this an experiment. We are experimenting on these people. Okay. And by the way, the results, if you're curious, yada 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 yada. Conclusions. Here they are. The use of hydroxychloroquine, according to this study, with or without the azithromycin, did not improve the clinical status compared to standard care. So the conclusion of this study, and what a lot of researchers have been saying, is that the hydroxychloroquine is not effective for COVID-19, despite what many people are touting online these days. Okay, so let's look at another study. Kicks from the penalty mark in soccer. The roles of stress, skill, and fatigue for kick outcomes. All right, so in soccer, we're talking about penalty shootout, a kick that happens at a certain point in the game. Let's skip to the chase here. So the purpose of the study was to use internet game record data to estimate the relative importance of these performance components for the outcome of penalty kicks in international matches. Data were collected from soccer statistics internet sites on all 41 penalty shootouts and 409 kicks taken in the World Cup, European Championships, and Copa America between these dates. And the results showed blah, blah, blah. So the question is, what kind of study is this? Is it an experiment or an observational study? So pause and think about it. Okay? So the answer here is that this is observational. We are not manipulating the environment under which these soccer players are interacting. We are just looking back at the data, and we're just looking and see what we got from it, what we can see from it, right? We're not manipulating anything. We are simply observing. And so that makes this an observational study. Okay. Okay, let's go to the last study here. Here we have the title on the left, The Effect of Age and Sex on the Perception of Time in Life. So what this study did is it looked at, let's just read the abstract here. As a measure of their personal perception of time in life, 320 participants completed the lines test. Participants were asked to mark off on a line their perceived present life location between the endpoint anchors of birth and death. So what they're being asked to do is to determine where they are in their lifespan. You know, we're born and then we die, and they're asked, pinpoint on this line where you think you are, right? And then they go on to talk about how results indicated a significant sex difference in which women across the age range investigated were more accurate as to their life location. So women did a better job of estimating where they were in their lifespan than men. And by the way, well, let me finish talking about this. So what kind of study is this? Is this an experiment or an observational study? So pause, think about it. Okay, the answer here is this is observational. Now this one might seem like an experiment because we have we have these technicians that administered this survey and they did this analysis on it. But if you think about what was really done here, nothing was really manipulated, right? People were just asked to mark off on a line where they thought they were, and then we just recorded these results. Now, we didn't manipulate anything as the researchers. So this is purely observational. The thing I wanted to point out is I actually looked this up. Where was it? Oh, the actuarial life expectancy. I was curious, what is that? What are they talking about? And I just thought this was kind of fun. It's on the Social Security website, the government Social Security website. It's kind of interesting. They have, given your age, they have your life expectancy. That's how many years you can expect to live, right? So if you are 4 years old right now, you can expect, and you're male, right? You can expect to live for another 72.5 years. If you're female, you can expect to live for another 77.5 years, right? And you can go find your age on here and see what your life expectancy might be. Get out of the way here. I just thought that was neat. So this is some neat data. If you want to go here, it's the ssa.gov website. You can just look at the actuarial life expectancy. It's kind of fun to look at. Anyway, that is all I have for you today. So I will see you in the next video.